Okay, here I'm going to solve a few absolute value equations that are not extraneous. So one of the ones is going to be number 5 here in the homework. So what you want to do is you have 3 steps. You want to first isolate the absolute value, which it is. That means this absolute value is by itself on one of the sides of the equations. You want to apply the KISS method, keep the inside, and switch on the second rewrite of the equation. And then on the third step, you're going to go ahead and solve both equations. So each one of these become 2 different equations you're going to write. So here's the absolute value of r equals 5. And so what we're going to do is first check if it's isolated. It is. Now we're going to apply the KISS method. So we're going to keep the inside of the absolute value the same. And we're going to set it equal to 5. And then we write the second part where r equals, and keep inside the same, but what we're going to do is switch the constant or whatever's on the right side of the equation. So that'll be -5. All right, and then third step to solve, but these are already solved because r equals these numbers, so these are already done here. Okay. For ones like number 6, you really got to watch out for those because absolute value numbers are always positive. So, and there's no way a positive can equal a -7. So when you have a situation, doesn't matter what's between the absolute value bars, it's going to be a positive number. And again, no positive number equals a negative. This is a no solution. All right, so for more simple type problems like number 7, so absolute value b minus 2 equals 5. Again, check to see if the absolute value is isolated. It is, so we're going to have b minus 2, keep the inside, set it equal to 5. Rewrite it, b minus 2, this time opposite the 5, which is -5. And then we're going to solve both of these equations. So I'm going to add 2 to both sides. And then we get b equal to 7. So there's one answer there. And then solve this one, add 2 to both sides of the equation. And then here we're going to have -5 plus 2, which is going to be a -3. All right, so there's that one, real easy one. Okay, another one that's been giving students a hard one is this a over 3 one. So keeping the same thing, absolute value is isolated. We have a over 3 equals 4. So I'm going to just rewrite those. So keep the inside, looks like a 9. Okay, equals 4, or a over 3 equals -4. Okay, so to solve this, all we got to do is multiply both sides by 3. Okay, these 3's will cancel. We have a equal to 12. So there's one answer. Same thing here, multiply by 3 both sides. Those 3's will cancel. A equals -12. And we got those there. Now number 12 is kind of challenging because if you don't isolate this, you're going to end up working this thing out, and this one actually ends up being a no solution. So when we say isolate, we need this part by itself. And the way we get that by itself is by subtracting 7 both sides. All right, so those cancel. We get the absolute value of x plus 4 equals a -4. Now, since it's isolated, we can now see, again, anything inside the bars is going to be a positive number. So there's no positive number that equals a negative number. So this ends up being a no solution. So this is the importance of having to isolate the absolute value equation first.